Welcome everyone. Welcome Professor Lewis. Here's my audience, also my family. Okay, so let's get to the presentation. Okay, so I'm talking to you here today in this video format because we're social distancing. Otherwise, I'd be in front of your lovely faces presenting you in class. Here's an interesting fact. Back in 1666, Sir Isaac Newton was social distancing himself from the bubonic plague. Newton's biography from SparkNotes notes 1666 as the miraculous year. 1666 was also the year that peaked Newton's achievements. This was the year that Newton compiled all his knowledge on calculus. Personally, I really enjoy calculus because I'm a math major and a math instructor at Mathnasium. Calculus is also an essential topic, and therefore I've came up with 3 parts to help us understand it today. Now let's look at these 3 parts. They include necessity, learnability, and applicability. Let's start with necessity. Necessity is the need you have to do something else. So how does that apply to calculus? Let's look at the 2 scientists that revolutionized calculus in the 17th century, my bad. Okay, so in the 17th century, 2 scientists were Newton, as I explained earlier, and Gottfried Leibniz. With Newton, he was famous for discovering gravity. As described by Why Did Newton Develop Such Complicated Mathematics from the Futurism article, it showed that Newton had a problem. He wanted to figure out how to understand falling objects. So, in order to understand this, I'm going to use this ball. Okay, so if we drop this ball, we realize that it starts off slow, but it speeds up while it falls. Newton wanted to figure out the ball's speed at each point while it was falling down. So if it was falling here, he wanted to figure out what its speed would be right at this point. In order to do this, he realized that there was no previous mathematics that could help him understand, so he had to come up with new math. It led him to inventing calculus. As John Green explains it, calculus is the math of objects that change instantaneously, or instantaneous motion. Okay? So, let's talk about the other scientist now. The other scientist's name was Sir Gottfried Leibniz. Leibniz was famous for something else. He was famous for finding area under irregular curves. But since we're limited on time, let's not go over this point right now. Let's go over it some other time. Okay? For now, let's get into our other point, which was learnability. Learnability is really important to calculus because a lot of people struggle with learning calculus. As Professor Dave explains in his YouTube videos, he says that students give up when they get to calculus. The reason they give up is because it's so new and they don't want to be learning it. They think that it's not important because it doesn't apply to them, so they give up. See, now this isn't true. We want to be able to learn calculus for many reasons. Okay? And different ways to do that are described by Vangelo Valuba from the Atlantic article. In her article, she says that there are many different ways to learn calculus, but the most beneficial ways are by learning informally before formally. Learning informally would include the example that I gave with the ball, where I would explain the concept of the ball falling. I would teach how each part of the falling ball works. Learning formally would be different because it would be talking about the math behind that ball. It would be coming into the numbers. It would be talking about the formulas. So it's important to learn the informal information before you get into the formulas of it. Okay, so now why is this important? Like, why do we need to learn calculus? Well, there are many reasons to that too, so let's get into the applicability. Applicability is important because it talks about how calculus can be applied to many different things. As described by John Marsh, he says that calculus can be applied mainly to finding areas, to economics, to engineering, and to biology. Areas, as I described, was created by Leibniz, and it's still used today in calculus. Now, let's get into a specific point. Let's get into biology. Biology ties into today's world, It talks about, because we're in a world where we have a pandemic right now. This pandemic, COVID-19, is something that calculus is used for. Calculus is very important to the COVID-19 pandemic. The idea is that the COVID-19 pandemic is increasing and spreading very exponentially. That's why there's a need for us to social distance. Well, how do we know that? This is because scientists use these different models to understand it. They want to understand the spread of the pandemic, and they can use calculus to see how they can lower the pandemic. They model different levels of social distancing in order to understand this change in the pandemic. Say you have 50,000 people in a society, and only 10% of them are social distancing. Chances are, also this is just hypothetical, chances are there's going to be about like 40,000 cases because there's going to be so many people that aren't social distancing. What's really important is that social distancing also increases and improves the results exponentially. So now as you go into 20%, you're actually going to see it half the amount of people that are actually getting infected. It would go down to 25,000. If you go into 30%, you'd get down to 10,000. So it's really important for us to social distance because it really helps us. And we know that because of calculus. So now let's connect these three parts. We know that calculus is built from necessity. And we know that from necessity, we know that we can learn it. We have to be able to learn it so we can apply it to different concepts. Biology was just one of the concepts I talked about, but it can be applied to a variety of concepts. That's what makes calculus so essential to our world today. Remember, keep these ideas in whichever career you choose to pursue.